In this two-dimensional momentum question, we have two masses, each 0.2 kilograms, one starting at rest and one moving at 10 centimeters per second, and makes contact at this on the second mass, but not right in the middle. So they end up going off in directions that are not necessarily in the same plane of original motion. So this is why it's a two-dimensional motion example. And we can see that mass number two goes off at an angle of 30 degrees above the horizontal with some velocity. Mass number one goes at 60 degrees below the horizontal at some velocity. And we're asked to solve for the velocity of mass number two. So there are several ways that we can do this. We can either just look at all the momentum in the x direction, we can look at all the momentum in the y direction, or we could even solve this using trigonometry. Our first solution is just going to use all the momentum in the x direction. So we're going to use our equation for conservation of momentum, which states that m1 times v1 plus m2 v2 is equal to m1 v1 prime plus m2 v2 prime. Now, of course, we can start to cancel some things immediately. We know that there's no v2 in terms of velocity, which means that this entire term is just going to go right to zero. So we're left with m1 v1 equals all of this stuff here. We can also cancel out all the masses because they are all the same. So this only works because the masses are the same. If they weren't exactly identical, I'd have to do a little bit more algebra throughout my work, but I can cancel m1s and m2s everywhere only because they all equal 0.2 kilograms, and therefore it's just going to divide out when I do some of my algebra. So this means I'm left with v1 equals v1 prime plus v2 prime. Now, I only want to consider the x direction worth of momentum. So I'm going to rewrite this because we can also do this using the y direction. So in my x direction, I have some v1, which is 10 centimeters per second. So this is my x direction only. And that's equal to the x component of v1 prime. So since there's an angle of 60 degrees below the horizontal, my x component is going to be the velocity times cos 60 plus my v2, which is v2 times cos 30. By rearranging and solving here, we end up with v2 equals 10 centimeters per second minus 5 times cos 60, which is just 2.5. That's again in centimeters per second divided by cos 30. We end up with a v2 prime value of 8.7 centimeters per second. We can do the exact same stuff here, making use of just the y direction. In this case, it would look like v1 equals v1 prime sine 60 plus v2 prime sine 30. v1 here actually just goes to 0 because you should note that there is no y direction velocity in terms of v1. So what you're left with is 0 equals -5, because of course it's going down, so we need to account for direction, centimeters per second times sine 60 plus v2 prime sine 30. By rearranging and solving, we're going to be left with v2 prime is equal to So negative 5 times sine 60 is going to be negative 4.33, but of course we're going to move that over to the other side of the equal sign. So we're left with 4.33 divided by sine of 30. And that again is going to leave us with 8.7 centimeters per second. And of course, these are positive values, which means that it's going up and to the right. We know the angle, so we can just say 30 degrees above horizontal. That would be the same answer here. We can also solve this problem using trigonometry. So the first thing we need to do is solve for the momentum of our first object or particle, which leaves us with P1 equals M1 V1. So that's simply 0.2 kilograms times, we're going to have to convert this into meters per second. So that's 0.1 meters per second. So 0.02 kilogram meters per second. And of course, that's to the right. So what does that look like in terms of a vector? Well, that would look something just like this, where this is P1. We know P2 is equal to 0 kilogram meters per second. We can also solve for the momentum of P1 prime because we know that value as well. P1 prime is equal to M1 times V1 prime. Putting that all together leaves us with the same mass, 0.2 kilograms, times the velocity, 0.05 meters per second. Of course, the direction is going to be the same as the direction of our velocity vector. So 0.01 kilogram meters per second. We're just going to say 60 degrees below horizontal. And of course, we don't know P2 prime, and that's what we're solving for. We can also make a really interesting statement here, which is going to take us to our next step. And that statement is that P1 plus P2 equals P1 prime plus P2 prime. But since we know P2 goes to 0, we can say that P1 equals P1 prime plus P2 prime. Well, of course, since these are vectors, this is just a vector addition statement. And we know that when we add vectors, we add them head to tail. So what does this actually look like? Well, we know that we have P1 prime, and that might look something like this, where this is 60 degrees below the horizontal. We have P2 prime that is going to look something like this. We don't know the magnitude, but we at least know the direction. That's 30 degrees above the horizontal. And we know that they end up, this is actually a little bit too long because we know that P1 is exactly horizontal. So we're going to have something like this. So that's P1, that's P1 prime, and that's P2 prime. So since we have a triangle and we have a bunch of information, we can solve this pretty readily. So I've redrawn my triangle here, and we can actually identify what we know. So I know these angles, or I know at least some of the angles here. I know that P1 is equal to 0.02, and I know that P1 prime is equal to 0.01. Well, if I have two sides and I have the angle across from the side I'm looking for, this leads me to using the cosine law. So the cosine law here is going to read P2 prime is equal to the square root of one side squared. So we're going to just say P1 prime squared plus the other side squared, P1 squared, minus 2 times the first side times the second side times the cosine of the angle across from the side you're solving for, which in this case is going to be 60 degrees. So if I substitute all of my values in, I'm left with 0.01 kilogram meters per second all squared plus 0.02 kilogram meters per second all squared minus 2 0.01 times 0.02. I'm going to probably run out of room, so I'm going to squeeze this under here times cosine of 60 degrees. If you take your calculator and you solve for all of that, it leaves us with a momentum value of 0.0173 kilogram meters per second. So don't forget that's not my final answer because my final answer is actually looking for velocity. So I actually know that the momentum, of course, is equal to the mass times velocity, which means velocity is equal to your momentum divided by your mass. That's going to leave us with exactly the same answer as before, although the units are a little bit different, 0.07 or 0.087 meters per second, which of course is equivalent to 8.7 centimeters per second, which is the answer we got in the previous examples.